From this video onwards, we'll be talking about solving logarithmic equations. And the first video on that is about solving logarithmic equations by direct conversion. Okay, so the core concept here is that we have a logarithmic equation of the form log x to base a equals c, and it can be written in the exponential form x equals a raised power c. So the base takes the exponent, on its head, and then that gives us x. I mean, we've seen that on how to convert between exponential expressions and logarithmic expressions. So this works because logarithms and exponents are inverse operations. We proved that, I proved that in the last video, I think, or in a video previously, that log is the inverse of ln. I mean, log is the inverse of exponent. Exponent is the inverse of log. So the conversion rule is that log x to base a equals c, and that implies that a raised power c equals x. And of course, if a raised power c equals x, it also means that the log of the base a, log x to that base a, gives us the exponent c. That's the core concept behind solving logarithmic equations by direct conversion. Of course, we've always known these conditions for logarithms. Before solving, you want to always check that number one, the base condition that a is greater than 0, first of all, and a is not equal to 1. Now, I think in a previous video, I had made this idea, thought about this idea that to combine these two, we just say a is not is greater than 1. That would be wrong because a can be a fraction. It can be 1 over 2, 1 over 3. It can be anything bigger than 0. It can be anything between 0 and 1, but it can't be 1. So 1 is you have to skip 1, and then so after 0 you can have anything from 0 to 0.99999. Then but then you can't have 1. Then after that you can now begin to have like 1 point something, and so on and so forth. So a greater than 1 won't work in that case. So that's something I like to take back. Then we have argument condition. So the expression inside the logarithm must be positive. Of course, you can't take the log of it. The log of a negative number does not exist. So log cannot take a negative argument. The answer will be it will be undefined, right? So the expression inside the logarithm must be positive. So whatever the expression is, like in the case of log x base a equals c, so x has to be positive by all means. That's one of the conditions of logarithm that we've seen already. So talking about step-by-step method for direct conversion, what do we do? First thing, you isolate the algorithm, the logarithm. So if there's something, maybe if there's a number multiplying the logarithm or something else somewhere, you want to take that away so that you can have the logarithm alone. And once you can isolate the logarithm, you can then convert to exponential form using the fact that log of expression to base a is equals c implies that the expression is equal to the base raised to power c. So after you do that, then step 3 says solve the resulting equation. And then after solving the resulting equation, you then want to also check the domain restrictions and reject invalid solutions. Since we know that there are certain conditions that must be met, for instance, any x you get has to be positive. So any negative x has to be rejected because you cannot take the log of a negative value. Okay, so that takes us to example 1. So you want to solve log to base 2, log x minus 1 to base 2 equals 3. So what do we do? First of all, we want to convert to exponential form, right? So you say, in that case now, from log x minus 1 to base 2 equals 3 means x minus 1 equals 2 raised to power 3. So 2 takes 3 on its head. So then you simplify. X minus 1 is now 2 raised to power 3, which is 8. Then, of course, from there, you solve. You can transfer, you can add 1 to both sides to remove the 1 from here. So in that case, you have x equals 8 plus 1, which is 9. Then the next thing is you want to check for restriction. So since x minus 1 is greater than 0, all right, it has to be true that x is always greater than 1. That means if x is going to be greater than 1, then the solution x is equal to 9 is valid, right? So if we had got something like, if we had got 1 as our answer, this wouldn't have been valid because the x minus 1 has to be greater than 0. That means x greater than 1, and in that case x equals 1 would not be a valid solution, but 9 is valid because it is greater than 1. So the final answer here is equal to 9. So that's the first example right there. So second example, we have to solve log x to base 5 equals 2. So we convert to exponential form. That means x is equal to 5 raised to power 2 And if we simplify, we have that x is equal to 25. And that's all we have. So if you check for the restriction, all we have here is x. So x has to be positive, and 25 is clearly positive. So if you check restriction, x is greater than 0. So the solution is valid, meaning that x is really equal to 25. So it's just straightforward. So again, we have log 2x plus 1 to base 3 equals 4. So convert to exponential form. That is 2x plus 1 equals 3 raised to power 4. Okay. And that means that you have 2x plus 1 equals 81. The next thing you try to simplify, and then to do that, you subtract 1 from both sides because we're looking for x. So you remove everything bothering x. Plus 1 is the first thing we can remove from here. So subtract 1 from both sides. So you have 2x equals 81 minus 1, which is 80. And then 2 is disturbing x. Still, divide both sides by 2. And then that gives x equals 40. If you check for the restriction, 2x plus 1 equals 0 implies that x, 2, it implies that 2x is greater than minus 1. And then if you divide both sides, it means x is greater than minus half. So, and since 40 is greater than minus half, then the solution that x is 40 is actually valid. So the final answer is that x is equal to 40. Let me go for example 4 again. For example 4, we want to solve log x squared to base 4 equals 3. So if you convert to exponential form, we have x raised to power 2 equals 4 raised to power 3. That is 4 carries 3 on its head, so to speak. And then you have x squared equals 4 raised to power 3. That's 4 times 4, 16 times 4, 64. So x squared is 64. And if we solve that, we discover that if you have x squared equals 64, then you take square root of both sides. That will be plus or minus 8. If you now check the restriction, this x squared has got to be greater than 0. So if you check the restriction, since the argument is x squared, it must be positive. So both x equals 8 and x equals minus 8 make x squared equals 64 greater than 0. So both are valid because x squared must be positive. So minus 8 squared makes it positive, 8 squared makes it positive. So our final answer in this case, because of the square, now minus 8 doesn't matter because we're going to square it and we still get 64. So x squared has to be 64 in both cases, and it's greater than 0. So that means x equals 8 and x equals minus 8 are both valid answers to the problem. And you can always check them out. If you put minus 8 here, you get 64. If you put 8 here, you get 64. So that works. Then, now, why does direct conversion work, right? So logarithms answer the question, to what power must the base be raised to produce this particular number? So the statement log x to base a equals c means exactly the same thing as a raised to power c. So to what should a be raised so that you can get x, and that is c. So a raised to power c equals x. They are equivalent forms of the same relationship. Okay, so what are some common mistakes you want to avoid when you deal with this kind of situation? So number one, forgetting that the argument of a logarithm must be positive. If you forget that, that's going to be a problem because you're going to admit wrong results if they exist. Then forgetting to check for extraneous solutions. So if you don't check for extraneous solutions, that can be a problem. Stopping after converting but not solving. So after converting and you don't solve, you have not finished because you need to solve for the unknown, maybe x or whatever it is you have as the unknown. Then missing multiple solutions when powers are involved. So when powers are involved, like in the case of x squared, you could have easily x squared equals 64 that we just did. You could have just said x is equal to 8, but in that case you have missed minus 8, and minus 8 is equally important. So when you have powers involved, you want to check for all the possible results. So if you have power 3, you have 3 results. Even if they are repeated, you want to at least you should be attentive to that idea. Okay. In summary, we see that to solve logarithmic equations by direct conversion, first thing, you isolate the logarithm. Second thing, convert to exponential form. Thirdly, solve algebraically. Fourth, check domain restrictions. And then the core identity is that the log of an expression to base a equals c implies that the expression is equal to a raised to power c. And if an expression is equal to a raised to power c, it implies that log of the expression to base a is equal to c. So we can go both ways. So practice problems, of course, this is where I've not solved anything myself all along. So I think I want to go for question 10. It looks the most challenging. So I think, so log x squared minus 4 base 3 equals to, okay, log x squared, log x squared minus 4 base 3 equals to, um, there's a way I get to mix things up when I say this. Let's check x squared minus 4, yeah? Log x squared minus 4 base 3 equals to. Okay, so what do we do? First thing, we want to write it in exponential form by making 3 carry 2 on its head, so to speak. So we have x squared minus 4 equals 3 raised to power 2. Okay, that means x squared minus 4 is equal to 9, right? So x squared minus 4 equals 9. That means that x squared is equal to 9 plus 4. All right. So x squared then is equal to 13. So that means that x alone is plus or minus square root of 13. So we have two solutions here. Now, but are those solutions admissible? That's the next thing we need to worry about. So we then check for domain. So so we check domain. So, and to check the domain, what do? We just take this expression, the argument x squared minus 4. We check x squared minus 4 has to be greater than 0. What that simply means is that x squared is greater than 4. That simply means that, so for x squared to be greater than 4, that means that x itself must be greater than, it must be greater than plus or minus square root of 4. If you take square root of both sides, that means that x must be greater than plus or minus 2. So what do we have? We have, so here now, originally we have x to be plus or minus root 13. Clearly, root 13 is something like 3 point something. Okay, so 3. So I mean, we have two parts now. I think we need to do a proper comparison. So for the actual solution, so for solution, we have we have roots. We have minus root 13, okay, and we have root 13, the positive. Then domain, what does domain tell us? Domain says that x must be greater than plus or minus 2. Of course, clearly, um, maybe we should just split it up. So clearly, minus root 13 is not greater than minus 2. Okay? So if you compare both, so if we look at, okay, maybe let's do it this way. Let's put the two together. So we have minus root 2 minus root 2 and plus root 2. So that's one. And then we also have uh, root 13 itself, or the solution, and we also have minus root 2 and root 2. So let's see. Now, minus root 13 is less than minus minus root 2. And minus root 13 is also less than root 2. So um, minus root 13 cannot be an answer. But root 13 is greater than minus root 2, and root 13 is also greater than root 2. So the only valid solution, okay, is x equals root 13. Okay, that's all we have for that. Minus root 13 won't work here. All right, so I take another question from 11 to 20. Which one looks the most challenging? Okay, maybe I should just take 20 because that involves a fraction. But is that such a problem? I don't think so, really, because I don't think it's such a problem because 9 raised per half is just 3, and we have x minus 1 equals 3, so x is equal to 4. And if you look at the domain, x minus 1 should be greater than 0, so that means x is greater than 1. So 4 is a valid solution. So since that is done, let me take something that has negative. Log x plus 4 base 5 equals minus 1. Log x plus 4 base 5 equals minus 1. Okay, so uh log log x plus 4 base 5 equals minus 1. So that means um we can take it to exponential form. 5 carries minus 1 on its head. So we have x plus 4 equals 5 raised by minus 1. And that means that x plus 4 is equal to 1 over 5. And then that means that x plus 4 is equal to 1 over 5 is simply 0.2. right? So that means x is equal to 0.2 minus 4. Okay, so x now is equal to 0.2 minus 4 is minus 3.8, I believe. Yeah, because 4 minus 0.2 is 3.8. So, but before 0.2 minus 4 will be negative now. So this is the result we have. So we need to check the domain, right? So we check the domain. X plus 4 has to be positive. So the domain, the domain is such that the domain is such that x plus 4, right? X plus 4 has got to be positive. So x plus 4 has to be greater than 0. That means x should be greater than minus 4. Okay, so x should be greater than minus 4. And what we got is minus 3.8. Clearly, minus 3.8 is greater than minus 4. So we can conclude that since since minus 3.8 is greater than minus 4, then x equals minus 3.8 is a valid solution, is a valid solution. And with that, we bring that to an end. So talking about solving logarithmic equations by direct conversion, we're done with that. So don't forget to try your hands on the questions. These are the first 10, and then we have the last 10 from 11 to 20. Try your hands on them and see how well you understand. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I must thank you so much for doing that. If you have not, what are you waiting for? Go ahead and subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join. That gives you some special privileges, like getting to see some videos first, or being only the only ones to see some videos because you're members of the channel. You can request for PDF copies, my PDF notes, with which I teach these things. I mean, there are many other privileges you can get. So just click on join and you see all of these things. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.